right, so we're looking here at 18E, rules for integration, okay? There's some applications. We've already looked at a rule for a constant, okay? If you've got a constant, all right, K, it's just K times X. All right, again, thinking about the derivative makes that one obvious. The derivative of a linear function is just the slope, which is a constant. All right, so the integral of a constant gets us back to a linear function, so Kx. We also know the power rule. The integral of x to the n dx is x to the n plus 1 over the n plus 1. So you add 1 to the exponent and divide by the new exponent. All right. We also talked about e to the x. E to the x is the nice one. The integral of e to the x is e to the x, because the derivative of e to the x is e to the x. Okay? Now, this is one where I want to add one element to something we saw earlier. And it's a little technicality, but it is important. Okay? Back here with the power rule, we said it doesn't work when n equals -1, because if we add 1 to the exponent, it's now 0. Okay? X to the -1 plus 1 is 0. That's okay. But then we would have to divide by -1 plus 1. We'd be dividing by 0, and that's undefined. Okay? But we did remember that the derivative of the natural log is 1 over x. Okay? Also, though, this is the part we didn't talk about. Okay? If we had the natural log of -x, using the chain rule, the derivative would be 1 over -x times -1. In other words, -1 over -x. So what you realize here is the negatives cancel out, and I still end up with 1 over x. Okay? So that's why it doesn't matter if x is positive or negative, you will still, when you integrate, get the same thing. Okay? Here, if we're in 1 over x, it's going to be the natural log of the absolute value of x. In other words, it's going to get us back to a positive x. Okay? So that absolute value part is the only part that we had left out earlier as we were kind of trying to make some observations. But now you see why that is. Okay? Now, sine and cosine. We saw a couple of these in our practice here by using derivatives, and I mentioned this earlier. Remember this pattern for derivatives: sine, cosine, negative cosine. All right? Remember we said if you're going down the pattern, you're taking the derivative. If we're going up the pattern, you're getting the integral. Okay? These are the only two brand new rules that we have for integration with this section. Okay? This section's kind of nice because it just kind of sums together all the different rules we've been learning here into one nice place. Okay? And the one really nice thing is these are the only rules that the IB is expecting you to be able to know and use. Alright? Like we've mentioned, there are a lot more complicated things that you can do with integrals. We're going to look at cases where these have a linear function within them, but that's it. So, the integral of cosine is sine because the derivative of sine is cosine. The integral of sine is negative cosine because the derivative of negative cosine is -1 times negative sine, so it would be a positive sine. Okay? So, the integral of sine is negative cosine. If you look again at the pattern, sine, we'd have to go up, so we're down here at the bottom at negative cosine. Okay? Alright, so those are some basic rules. Let's practice using some, okay? See, don't these look a lot nicer than the ones you were doing for practice? Okay? So let's work our way through these. We're going to integrate with respect to x. So let's get our notation. The integral of 2 sine x minus cosine x dx. Okay? What's the integral of sine? Negative cosine. So what's the integral of 2 sine?
Negative 2 cosine.
Negative 2 cosine. There we go. Negative 2 cosine of x. And then what's the integral of cosine?
Negative sine.
That's the derivative of
Oh
cosine.
yeah, my bad.
It's positive sine. Okay, so we have minus a positive sine x. Okay, and then don't forget your
Plus
constant, plus c.
That's so good.
Okay, not too bad, right?
Can we have a quiz on that?
All right, we will Friday.
Not formative.
Formative quiz.
No.
So,
Formative Friday.
Formative Friday.
Negative 2.
Formative is so mean, like it creates expectations and then
God
just
forbid.
drops.
The opposite.
All right, so any questions about this one though? You got the idea?
Yeah.
Let's try this one here, okay? We have the integral of negative 2 over x plus 3 e to the x dx. Okay? There's a bit to work through here. It might be helpful.
Isn't it ln?
Okay, there's going to be an ln. Let's actually break this up so maybe we can see it a little easier. I'm going to take the negative 2 outside. So it's the integral, negative 2 times the integral of 1 over x dx, plus, and I'm also splitting this into 2 separate integrals, because addition, remember we said we could split it up. So plus 3 times the integral of e to the x dx. Okay?
Okay, so it's negative 2 times ln
ln of
X.
absolute value of x.
dx.
Well, the dx is gone because we took the integral. That was
Oh,
part of
okay.
the integral notation.
Plus 3. I don't know how we do that.
What's the integral of e to the x?
E to the X.
E to the x
Plus,
And then-
about the constant.
plus c. Okay? You don't need to put plus 2c because we had 2 different integrals. Okay, just put a plus c.
For A, you took out the 2 because of the constant.
Yeah, you could have rewritten a as 2 times the integral of sine x dx minus the integral of cosine x dx. Okay? So sine is negative cosine times 2 is negative 2 cosine minus integral of sine of cosine is sine. Okay? If it helps you to write it out that way, do it. Okay? It's better to do a little bit more writing and get it right than to just kind of guess at it and get it wrong. Okay? Especially here at the beginning. Alright, now, another thing though that we will need to be able to do, because we don't have a chain rule, we don't have a product rule, we don't have a quotient rule when we're integrating. And we're also not going to learn any kind of u substitution or any of the more advanced techniques. We will, however, need to be able to handle certain cases like this. Okay? So, we're taking the integral of 3x plus 2 over x quantity squared dx. And the only way that we're going to be able to find this integral, since they didn't tell us, by considering the derivative of this function, tell us what this one should be, okay? We're going to have to expand this. So, I'm going to have to take the integral of what? What would I get if I FOIL this?
9x squared.
Plus 6, yeah. Plus another 6 plus what? 4 over x squared, right? Okay, so when you FOIL it,
Wait, why is it 6 plus 6 in the middle?
because you got the outers and then you have the inners.
'Cause
3 times 2
oh,
it.
okay.
Yeah.
Okay, makes sense.
You'll get 2 6s there. So we get, just to kind of rearrange it
I
here,
was using the formula in my head.
You know different
What
from
does it mean?
4 over x squared, sorry, 4 over. Alright, so look, now we're able to use the power rules, okay? And actually, I'm going to rewrite this 4 over x squared to make it easier on myself too. I'm going to write that as, what do you think?
4x negative.
Very, very good. 4x to the negative second power. Okay? Alright? Now we can just work through our power rules. So, we add 1, divide by the new exponent, so we got 9x cubed over 3 plus, what's the integral of 12?
Integral of 12 would be 12x plus the 1 y.
12x, yeah. And then what's this one?
That would be plus 1.
If you go 4x
No.
to the negative first,
Negative
first one.
There we go, good, okay. So we've got all of that. Well, we should simplify a bit here. This is 3x cubed plus 12x, and this would be minus 4 over x. And then we always throw in our plus c at the end. Okay? Okay? Alright. Let those who are departing know. And we're going to look at one last example, and then I'm going to let you guys practice a bit. Okay? See ya. Thanks, you too. Bye.
So you are doing after like the game fight.
5B, I have meeting with somebody already.
Oh.
So, yeah. But we do need to get together and talk stuff over here.
I'm getting a bit ahead of myself with B, but
Okay.
I was wondering, like, would you make that x 1/2, and then, so you know how, I know that there's a rule that if you work downwards, you subtract it. So like, x squared minus x 1/2.
Okay.
Or am I,
What do we subtract? What do we subtract in that case? Here, guys, we're gonna need to rewrite this. Okay, we are getting a little ahead.
Yeah.
Let's catch up here. If I have a quotient like this and I have a monomial in the denominator, I'm gonna need to simplify this quotient by splitting it into an x squared over square root of x minus 2 over the square root of x. Okay? Notice I have to keep the denominator the same for both parts. Okay? But I'm reducing, I can now reduce this one, and I have the integral of, what are we actually subtracting here? It's not x squared minus x to the 1/2, it's,
2,
yeah, we're just subtracting the exponent. So it'd be x to the 3/2, or 1.5 power, okay?
and then the other one remains the same.
Yeah, the other one will stay the same. I'm going to write it as a negative exponent so I can use the power rule a little easier. Okay? So notice the challenge here isn't really the integration, it's just getting to the point where we can do the integration. Alright? Now we've simplified it to a point where we're just using the power rule. Okay? So what would I get with the x to the 3/2?
2x to the 1/2. Right? It's 1 and 1/2 minus 1.
It's 2 fifths times x 5 over 2.
5 halves, good. Over 5, right?
Yeah.
Because it's
Then you
5
add
halves, so
one.
now it's over.
Because when you
5.
add 1, it's 2 over 2. 2 over 2.
Yep. Yep. A lot going on here, I know. Okay. So then minus,
Or,
Times x through.
or no, never mind.
yeah, it would be x to the positive 1/2. All right, 2x to the positive 1/2 divided by a half, which is times 2. So you were right, there would be a 4 here. Okay. All right. And then, let's see. There's nothing really to simplify here. We can leave it like that.
Wait, why would you make it over 5?
Because of the 5 halves, you're dividing by the new.
So why would it be 5 halves?
Because 2.
Well, we are dividing by 5 halves, so we flipped and multiplied, so it's
Oh,
times
okay.
2/5.
Okay.
If it helps you to think in terms of, instead of dividing by the new exponent, think of it in terms of multiplying by the reciprocal of the new
Okay.
exponent, that might help on those fractional exponents.
Okay.
Same thing here, we divided by 1/2, so it was times 2. That's how we got the 4. Alright. So. Okay. So that's all of the new stuff. I'm going to stop this here.